Okay, so we're continuing to build graphs for data taken from a sample. And again, we're really dealing with data that's at the interval or ratio level. So we did a histogram, and now what we're going to do is called a modified histogram. So it's basically a histogram with some changes to it. So step one, just like before, is to get our blank graph space established. So there we go. It's ready. So what's the modification? Well, it should be fairly obvious. There's no frequency axis. It's just the x-axis. It's just the raw score axis. So we draw the line, we evenly split up and number our spots, and we label it. Again, if we knew what kind of scores these were, if this was number of free throws made or something, that's what we would write down. But it's a generic example. X stands for raw score, so that's our label. So we're done. It's built. Now we go ahead and start to plot our data in here. So we do the same thing, generally working left to right. So we look for our lowest value score, 1, and there's 2 of those. So what I'm going to do is stack 2 blocks right on top of that spot. Raw score of 2. There's 3 scores of a 2. There are 5 3s. There were 3 4s and 1 5. That is a modified histogram. So why is there no frequency axis? Because for a graph like this, it just wants us to count. How many scores of a 2 were there? 1, 2, 3. Count the blocks. Get your inner 2-year-old on. Stack them and count them. That's all there is to it. That's a modified histogram. I'll be honest with you, I cover it because it's in the book. I'm not sure exactly why they put so much emphasis on it. There are other types of graphs we could be talking about. Really, again, for samples with interval or ratio level data. Notice that the graph ends up looking the same as a regular histogram overall in terms of sort of the shape, the sort of overall profile of the thing. It's not used that often, and you can probably imagine why. I mean, first of all, you're drawing it by hand. You can see what a mess that is. All the boxes need to be the same size, so a computer can do that for you. But imagine we were dealing with a large sample, like a true research sample that had 150 people in it. And the scores of 3, there were 37 scores of a 3. Do you really want the reader to count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13? I'm sorry, what did you say? 14? What? Oh, man, I got to start all over. 1, 2, 3, right? It's a lot of little boxes to count. It can lead to errors. So, but if we've got a small little sample data set like we do here, it's just 14 scores, we could do this. It's not right or wrong. It's a matter of what is the correct communication tool for your audience. If you think that this is the correct way to present the data to your audience so that they can best understand it, then this is the graph you use. If you think a regular histogram is the one that you should do, then that's the graph you use. Or our final option on this particular topic is what we call a frequency polygon. Usually I just say polygon, but technically its name is a frequency polygon. So this is a third tool to do the same job. We're trying to make a graph for data taken from a sample at either the interval or ratio level. So it's just a third option that we have available to us. So with the frequency polygon, step 1 is the same as it is in all the other ones. Get your workspace set up. So the first thing we got to do is get our workspace set up. So we're going to need axes, numbers, and labels. That's about right. And now our raw score. So, what makes this setup different than the histogram? It's exactly the same with one small difference. If you look at our raw scores, our highest raw score is a 5, but I've actually went 1 past. So when you're setting up your graph for a frequency polygon, you need to go 1 higher than your higher score. We'll see what you need that for in just a second, but you always go 1 past what you think you needed there. Now, instead of stacking blocks or building bars, we're going to make dots and eventually connect the dots. So now we plot our data. So same as always, raw score of 1, I go to raw score of 1, there's 2 of them, so over to 1, up to 2, and I put a dot there. Raw score of 2, there are 3 of those, over to 2, up to 3. 5 3s, 3 4s, 1 5. So now all the dots are on there. So now we just simply, with straight lines, as straight as we can manage, connect the dots. As we'll see in a minute, curved lines mean something else. So, all right, so that's the next step. So we made the axes, numbered and labeled them. We put the dots, we connected the dots, and now the last step is to ground it. We have to attach this squiggly line down to the ground. We have to close the figure to make it a true polygon. Polygon is a closed figure. So you look to see what your highest score was, 5, and you ground it, just draw the line down to 1 category higher than that. So 1 category higher than 5 is 6, so we just go over to the 6. We look at our lowest score, 1, and we do the same thing but the other way. We go down 1 lower than that score. 1 spot lower than 1 is a 0. So that would take us right down into the corner. It does not always go into the corner. If our lowest score was a 3, you'd ground it 2. If your lowest score was 1,000,000, you'd ground it 999,999. Whatever your lowest score is, you go down by 1. Whatever your highest score is, you go up by 1. But we can see that we've ended up with essentially the exact same thing as the previous 2 graphs. Again, none of them is specifically right or wrong. They're choices. So as long as our data comes from a sample and the data is at the interval or ratio level, any 3 of those choices would be appropriate. They're all equally good. It's just a matter of who are you trying to communicate with, and so what's going to be the best tool for getting that done. That's all that really matters here. Now remember, just like with frequency distribution tables, if we were missing data, we said before, if we had no 2s, if it turned out that there weren't any 2s there, we said we include it on the table. We don't just skip over it. The same thing happens here. What we would do if there were no 2s, what we do not want to do is just go, well, there weren't any, and just connect straight from 1 to 3. Because the reader's going to look at that and say, well, were there 2s? Did they just not put the dot for some reason? What's going on? So we want to actually chart it out. We want to actually put the dot at 2 and 0 and connect those dots. So it should look like that if there were no 2s. For the modified histogram and the regular histogram, there just wouldn't be a bar or stack of boxes. So we wouldn't go 1, 3, 4. We would still, 1, 3, 4. We would still leave the 2 there. I'm sorry, I was correct the first time, 1, 3, 4. Still makes the 2, there just wouldn't be a bar above it or a stack of blocks above it. So this is if we are building graphs for sample at the interval or ratio level. So in the next one, we're going to look at what do we do if our data is from a sample, but we're at a nominal or ordinal.